Good morning students, welcome back to CS class. In today's class, I'll explain you about the file handling in C. See, actually whatever programs we executed previously and whatever output is generated from that program, that is erased from the memory when you open another window, because whatever content is generated, that is means that is not that we are not saving. So what happened, that is erased from the content. But in future example, whatever content is generated from the programming and that content you want to save permanently, then what you have to do is whatever output is generated from the C programming console, that should be transferred to any text file, and that file you can save permanently on the hard disk. So whenever you want to see the output, you can see, and if you want to copy that output again into your program, you can copy, you can modify, you can delete. Okay, so it is possible by using a files concept, and files concept incorporation in a C programming. So here whatever output is generated, that output, if you want to save permanently, then what you have to do? You need to transfer, you need to copy whatever content is generated in the console to the text file. Okay, so that is a file handling mechanism in a C. So here the same thing I have given as a definition. In C programming, we may require some specific input data to be generated several number of times, or sometimes it is not enough to only display the data on the console. Means if you want to save the content, and if the content is very large, and you want that content in future, then what you have to do is you need to copy that content into any other text files. That is nothing but the file handling. Now in C programming, file handling allows the user to create, read and delete the files. So you can create a new files, you can delete an existing file, and whatever content is there in a files, that can also you can read. That also you can read, and it is possible in C programming. Okay, so in file handling is nothing but it is a collection of different functions like a create, update, delete and all. So here I have given a list of the functions which you can operate on files. First one is a creation of a file, opening an existing file, reading data from the file, writing data to the file and deleting a file. Okay, see, creation of the file. You can create a new file, new text file from a C programming, and whatever file is already there, that you can open using a C programming. You can read the content from the text files, you can write content to the text file, and you can delete the files, using a C programming. Okay, see, files, I said file, for what purpose we are using a files. What is the objective? Why we are using a files concept in C programming? See, when program is terminated, the entire data is lost. See, whenever you close the program, whatever output is generated, whatever content is there, that is lost. But if you want to store that in a program after the termination, you want to save that files permanently, even after terminating a file, then we can use a files concept. That is the major purpose of the files concept in C programming. Now here you can see how many types of files we have. See, there are two types of files in C programming. One is a text file and the second one is a binary file. Text file example, if you will take a notepad, notepad is a text file. So in the notepad, whatever files you are saving, that are stored sequentially and that are also read sequentially. If you want to read the fifth record, you should start from the first record. Means it supports the sequential access text file. And in case of a text file, we will store only the text. Okay, stream of characters will store. Now the second one is a binary files. Now you see the text file. text files are means whenever you create a text file and whenever you save the text file, it should have the extension, it should have the file format as .txt. Okay, it should have the file format as .txt, and it is easy for the user to create the text file, to edit the text file, delete the text file, modify the text file, which everything is easy when you are dealing with the text files. Now the next one is binary files. See, binary files, for all binary files the extension is .bin. bin, it's nothing but the binary. Okay, so whenever you see the binary files, whatever content is there in the binary files, that is in a zeros and ones format. See, binary means how much? It is only 2 bits, that is a zeros and 1. So if it is a binary format, binary file, it contains data in a zeros and ones format. And binary format we can store the large volume of data, but it is difficult for us to read, modify content in the binary files. Actually, binary files, when you will get the binary files, after compiling a program, whatever file is generated, that is nothing but the binary file. In case of Java, after the compilation, you will get the dart class file, that is a byte file, bytecode file. So in case of C programming, after the compilation, we'll get the binary file. Now, what operations you can perform on files? What operations you can perform on the files? Here I have given list of files. You can perform a list of operations you can perform on the file. First one is you can create a file, you can open an existing file, closing a file, and reading data and writing information to a file. Now come to the programming part. See, when you are working with the files, example, if you want to open a file, if you want to close a file, if you want to delete a file, whatever operation it may be, we need to declare a file pointer. So like a variable you will declare, no, int a, b, c. But when you are dealing with the files concept, you need to declare pointer type of a file. See, in this example, asterisk fptr. Asterisk fptr is a pointer type. It's a pointer variable, and which is a type of a file. Okay. Actually, what is the use of the pointer variables? It is used to store the address of another variable. Yes or no? So here, asterisk fptr is a variable of file type. Okay. So means it is used to store the address of the file here. fptr is a variable, it's a pointer variable. Always pointer variables are used to store the address of another variable. So if the fptr is a pointer variable, it is storing address of another variable. Okay. Now here, the next one is, you can see the next one, opening a file. Okay, opening a file means it is already there. You want to open a file. See, example, if you want to copy the content, the first thing is you need to open the file. After opening the file, you need to copy the content to the file. Okay, so here in order to open the file, here we are using a function called fopen. Fopen is a function which is used to open an existing file. Okay, see here, syntax for opening a file. The syntax for opening a file here is ptr equals to, see, I declared ptr already. Actually, it should be fptr. Okay, fptr, ptr equals to fopen. Here fopen is the method. Okay, what is the fopen? Fopen is a method. And what is the use of this method? This method is used to open an existing file. And whatever file you are opening, no? And for that file you need to give the mode of the operation. Means in that file you want to write the content, you want to read the content from the file, Okay, such operations means R means reading a file, W means writing into the file. So that is called as a mode of the operation that you have to mention in this method as a second parameter. PTR equals to F open. F open is a method, and using this method we can open the file. So file open, file to be open actually it is, means which file you want to open, that file name you should give here, file name, comma, in which mode you want to open, means whether you want to read the content or whether you want to write the content, what type of, means in which mode you want to open the file. That is nothing but the second parameter. For example, you see F open is a method. In E drive in C programming folder, new program.txt one file is there. That file I want to open and I want to write a copy, I want to write content into that file. See here you can see W have given, W for writing mode. Which file you want to write? The file which is there. What is the name of the file here? New program.txt. TXT means what type of file it is? It is a text file. Next, where is that file? C programming folder. Where is the C programming folder? In E drive. Okay, so E drive, C programming folder, new program.txt is a file. I want to open that file, and in which mode you want to open that file? I want to open that file in a writing mode because they have given W. Okay, now in case, say here you see the pointer below the syntax example. Suppose the file new program.txt does not exist. Example, that file is not there in the system in the location of E and C program. The first function creates the new file named with new program.txt and open it for writing as per the mode W. Say example, here what is the name of the text file? New program.txt. If that file is exist, that file will be opened and something is to be written into that file. Suppose if that file is not there in the given location, then first thing is that file will be created, and after creating that file will be opened in a writing. Okay, if I'll give R, the file will be opened in a reading mode. If I'll give W, the file will be opened in a writing mode. Now F open over. Next one is F close, closing a file. See the file, both under the file, it may be a text file or it may be a binary file, whatever file it may be. It should be closed after opening, after reading and writing. Whatever actions you want to perform, after performing, you need to close the file. Okay, we'll open the file by using a F open method, and whatever file is open, you can close that file by using a F close method. Okay, and when we'll close, after performing all the actions, we'll close the file which is already open. So here you can see F close, FPTR. F close is a function. And what is the use of the function? That function is used to close the file after the modification. Okay, see FPTR. FPTR is a pointer variable. What is the FPTR? FPTR is a pointer variable which is used to close here. Okay, means the valuation and whatever is there in that execution now from right to left, whatever file you have given in the bracket. FPTR. FPTR is nothing but it is a pointer variable, stores the address of new program.txt, and that file we are closing by using a fclose method. Now here you see the example program. See, the first one is a preprocessor command, #include stdio.h, #include stdio.h. It is a standard input and output header file. The next one is standard library.h, because here we are using a library files, fopen and f close. So that is why here I am including std lib.h. Okay, so we are getting this f open and f close two functions from std library.h. So that is why here I am including this preprocessor command standard library.h. Here you can see the first and second line. Main function. Inside the main function, how many variables I declared? Two variables I declared. One is a type of integer and another one is a type of file. See, number is a variable which is a type of integer and fptr is a variable type of a file. Okay, and fptr is a pointer variable. Now you see here fptr equals to it's a pointer variable. So for that pointer variable, here we are assigning the address. F open is a method. What is the use of this method? This method opens the file. Which file we are opening? The file which is there in the C drive programming.txt file we are opening, and that we are opening in a writing mode. Okay, that we are opening in a writing mode. Now we are trying to open the file. What file we are trying to open? Program.txt I want to open. Example, if the whatever file you are searching, whatever file you are trying to open, that is not exist, then if fptr equals to null, means what it means, whatever file you are searching, that file is not exist, then you will get an error. In case if it is exist, what we are doing? Printf, enter the number, means the above condition false. What it means? File is there. See, the above condition true means what? File is not there. If the above condition is false, what it means? File is exist. So if the file is exist, we are opening and we are taking one number from a user, and that number we are storing inside that file by using a printf. Printf is an output function, right? So it is used to store something, it is used to print something. So where it is printing? Inside the file it is printing by using a printf. See, printf fptr. fptr is the location of the file which you have opened. Percent is a format specifier and a number. Whatever number you are taking from a user at runtime, that number where we are storing in fptr. What is the fptr here? The file which you have opened. Now close fptr. We are closing that file. Now come to the binary file. Reading. Just know f open and f close, that both functions related to the text file. Now we are whatever I am going to explain you, that is about binary files. See, here we are using two functions, fread and fwrite, for reading data from and writing data to a file on the disk respectively. Means whatever binary file is there now, that content you can read by using a fread function, and you can write some content into the binary file by using a fwrite. Now when you are using a fwrite and a fread function, this function takes 4 parameters. Okay, this function takes 4 parameters. I said no, parameters means after the function name in the bracket whatever you will give, that are called as a parameters. So here in a fwrite and a fread, two functions are taking 4 parameters. First one is address data. Address data means nothing but it is a pointer variable. It gives the address of the data to be written on the disk. To which file you want to write the content. Next, size of the data to be written in the disk. How much data you want to write into that particular file. How much data you want to write in that particular file, that size of the data also you should give. And a number of such data, how many times the same data you want to enter, and pointer to that file where you want to means where you want to add the content, at the beginning or at the ending or at the middle. That is nothing but the pointer to the file. 4 parameters are important whether you are writing content into the file or you are reading content from the file. Here you can see the syntax. Write, address data, size data, numbers data, pointers. Example, see here. 2 preprocessor comments I am including, and I am creating one structure, struct. Here one character space should be given between 3 numbers and a struct keyword. And how many data members I have given inside the structure? 3. N1 comma N2 comma N3. 3 members I have given. Now come to the main function. One integer variable I declare and struct 3 number. Struct 3 number and num keyword I have given. Actually a character space should be there here. Okay. Struct keyword there, no? This is struct keyword. So it is after modification. Struct, I am creating one structure with the 3 members, right? Next, inside the main function you can see struct 3 number. 3 number is the name of the structure, and I am declaring one variable num. Okay. And I am declaring one pointer variable file asterisk fptr file, and fptr is a pointer variable of type files concept. Now here you see if fptr equals to open, this point already I have explained, dot pin, if it is null then what happened, whatever file you are trying to open, that file is not exist. Example, if the file is exist, then what we are doing, I said no, here we in using the fread function or fwrite function will give the 4 parameters. Ampersand number, size. Ampersand number means which record you want to update, that is the address of the record, comma size. What is the size? How much size? See, size of the structure. Struct the 3 number. Example, 3 members you have. 3 members of integer. So total 6 bytes of memory. 6 bytes of memory we want to store. Next 1 means whether you want to read from the starting or you want to read from the ending. Next fptr is nothing but the file. Next we are printing. That's it. So this is about binary files. Okay, so binary files, inside the binary files we are storing content in the form of zeros and ones. If it is a text file, normal text will enter, but whatever content you are entering and whatever content you are copying from a console to the here actually finally we are copying content from console to the notepad file or any binary file. The next one is random file access. Actually file access means what? Whatever content is there in the file, that if you are reading, okay, you are reading, you are opening, then that is nothing but the accessing a file. Okay, so in accessing also there are 2 types of accessing. One is a sequential access and the second one is a random access. Sequential access means what? Whatever records there in the file, no, that records are accessed, read sequentially one by one. Example, if you want to read the 10th record, you should come from the first record, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, like that. That is called as a sequential access. And when will follow the sequential access? When you have a small content, a file with the small content, you have only few records to read. In that case, you can go for the sequential access. Okay, but if you have a large content, a large number of records, Sequential access is time consuming. It's not that, it means that the method not gives that will not increase your program performance. Okay. So if you have a large data number of records to read, then instead of sequential method we can go for the random access method. In the random access method, you can read the file wherever you want. Means you no need to read from the beginning, you no need to read from the ending. So from wherever you want to read the content, from that particular point you can read the content. That is called as a random access. Okay. See here, here we have given random file access means that you can take the file pointer to any part of the file. Means an example, if you have a file, you have a 10 records, you want to read the 6th record. Directly we can go to the 6th record and we can read the 6th record. So that is nothing but the moving file pointer to the desired location. Okay. See example, here I have given total 1000 records you have, and if you want to read 9999 the record, then you can directly point to that file. You no need to read the files which are before the 9000. Okay. So whichever record you want to read, directly you can go to that record and you can open that record using a random access. Okay. Now here random access is possible by using two functions. First one is fseek, the second one is a ftell. Fseek means, actually, see here I have given the definition. Fseek function is used to take the file pointer to the particular position. Okay. So what is the fseek function? Fseek function is used to move the file pointer to the particular position. Just now in the example what I have given, you have 1000 records, and if you want to read the 999th record, then using this fseek function, directly you can go to that file pointer. Okay, you can go to that particular record. That is a fseek function. See fseek, you see file pointer, position, initial. See file pointer, I said fptr. File pointer is nothing but the name of the file pointer variable. As I said already, fptr is nothing but which points to the file. It stores the address of the file, and that is the first parameter. Second parameter is the position. How many characters you want to jump? Means how many records you want to jump. Example, if you want to read the 10th record directly, then you need to jump the first 9 records. So that information you should keep. The third one is initial. Initial specifies the position from where the file pointer should be jumped. Means from the ending you want to jump, from the starting you want to jump, or from the middle you want to jump. That you can give by using initial. So for initial here we have a 3 values. If it is a 0, means you want to jump from the beginning. If it is a 1, you want to jump from the current position. If it is the 2, you want to jump from the end of the file. Okay, so three values you can give in the third parameter. Now you can see the example program. File asterisk f1 is the file pointer, means it is used to store the address of the file where you want to read. Now here I am creating one array with the size 80. Which file I am opening? Data.txt. See, before, if you are giving a data.txt, you try to create that file first, and I am opening that file in a reading mode. Okay. And next, fgets. This function is used to get string from a user at runtime. So and that string size is 80 characters. Okay, 80 characters, and here you can see the first parameter line, comma 80 and f1. Okay, now I am printing that same. Fseek, already 80 characters are there. Fseek is a function which moves the file pointer to the desired location. File pointer f1, comma 2. 2 records I want to jump, or 2 characters I want to jump. 0. 0 means what? Here from the beginning. So 0 means we are jumping from the beginning, means we are leaving first record and second record, directly we are going to the third character. See 20 characters. In the 20 characters, I want to directly read the third character. So that is why they have given 2. 2 means we are jumping the 2 characters and we are moving to the third character. Next I have given fseek f1 comma 2 comma 1. Third parameter I changed. Means instead of starting, I am giving 1. 1 means what? Current position. 2 characters jumped on the current position, like that. And we are closing the file. The next one is the ftail function. See, this function tells the current position of the file pointer. Where is the current file pointer currently? Means it is in the first character, it is at the third character, it is at the fifth character. Where is the file pointer? Okay. Now, asterisk f is the file pointer and I am creating an array with the 50 characters. Now, which file I am opening? Contents.txt, and I am opening that in a reading mode. F gets 50 sentence, 50 and F. 50 characters we are taking from a user at runtime. Now, fseek file pointer -1 comma 2. Okay, this file pointer is placed at the last character from the end. Okay, means at the last position, last character. And we are printing that. After printing that, we are closing. So only 2 points you need to remember here. One is the fseek function, which allows the user to go to the desired location from where you want to read the content, and ftail function, which it tells the what is the current position of the pointer, means where it is, where it is at the beginning or it is at the ending, where is the actual position of the file pointer, that you can find out by using a ftail function. Okay, so this is about files concept. Okay, in the next class we will start the revision. Thank you.